Hello one and all, and most welcome to my channel. Thank you very much for subscribing my channel. Your subscription will persuade me to further create and upload new tutorials. Okay, so please do not forget to subscribe this channel for those who are new here and did not subscribe yet. Okay, so in today's lecture we will discuss about how to model a structure in PERFORM-3D, which is the analysis software, and how to proceed with modeling and analysis phase. Okay, so in previous tutorials I was also discuss about how to model a structure and some portion, and it is analysis phase. Okay, in this tutorial I have received this structure, which is transferred from ETABS software, and I have made some changes in its modeling phase, and I have completed its analysis phase. Each and every step in this tutorial you will learn about. Okay, so when you just transfer this structure from ETABS software, so you will just open it. Okay, as a normally you're opening from here, open an existing structure. Okay, so if you do not know how to transfer and export a structure or a building from ETABS SAP 2000 or another software, please watch my previous tutorial, which a link is in the description, is also available. Okay, so you will know how to transfer or export a structure from another software to PERFORM-3D. Okay, so I have opened this structure. Okay, from here open an existing structure, and you will specify its location and browse it. Okay, so like for instance I have this structure, okay, which is in this folder, it is name, and I will open it. Okay, so the PERFORM-3D software will open this structure. Okay, this is a structure name. Okay, this is units. Okay, and it is showing that in its descriptions means this model is transferred from another software, and here you can just choose the minimum spacing and save the changes after every 5 minutes or 10, 20 and 40 whenever. Okay, it is up to you. I will just press the OK, and I will choose here the modeling phase and here as a node. So this structure, I was created the structure in ETABS software, and I have applied the moderate earthquake. Okay, after analyzing it, I have transferred the structure, exported the structure to PERFORM-3D. So I have done the moderate earthquake analyzation because without analyzing in other softwares I would not be able to transfer or export the structure to PERFORM-3D. So make sure to perform the moderate earthquake. So here then in PERFORM-3D I have done for maximum credible earthquake. Okay, I have analyzed this structure. Okay, that is so this is here will be the overall information which I have explained to you, and here will be the node. So how to create the node, and it is like the initial steps I have explained in previous tutorial. If you do not know, it is like you're in very beginning level, so watch the previous tutorials. I will put also the previous tutorial links in the description box. Okay, so this is the structure. So there is no need to there will be not very much burden here in this structure or this software, because I have already designed the structure and modeled the structure in another software. I will just do some very minor things here, so then I will be able to proceed further. Okay, so like nodes, there is no need creation required. Supports I have applied in previous structure, in previous, and this is the masses. Okay, and you can just look to it. Okay, this is like you can just if you do not have masses from another software, there is no need, you can just apply it as a diaphragm. You will see individual node for every individual floors. Okay, this is just showing as I have transferred from another software, but there is no problem as a mouse look like this one. Okay, and here is the constraints. Okay, if you have like constraints, I have like many constraints, and it is showing for each and every floor. Okay, like this structure is 30 story, 30 story. Okay, look here, 29, 30. Okay, so means it is showing constraints. Okay, for each and every story. Okay, sorry. So look here. Okay, like it is showing one will be starting from here. It is just in reverse, but no worry, it is just showing and indicates for each and every story. No problem when it is starting from 30 or 1. It is just numbers. Okay, so afterward I will come here to the component properties. So I will explain here other structures I have transferred and exported from other software. So if you do not know about each and every individual components here, watch another tutorial that will help you to understand much more about this software. Okay, so here is the inelastic properties, where I will first talk about material properties. Okay, so like material, I am coming here to inelastic one-dimensional concrete material. So I have defined here, and so like concrete. Okay, for beams and columns, this is the material properties. Here you can just look here, modulus of elasticity, and also other properties here, strength losses. Okay, so you will just see here, and you will choose here shape relationships here, and tension, strength. Okay, strength losses. So you will see all the information here. So these properties will be will be the reference from ETABS software. Okay, because I were defined these properties. Okay, in that case. So if you do not have these properties predefined, please define and assign here. Assign will be another case here. I will show you. So afterward, I'm coming here to the string section. So here I will show you the strength about, like it's showing moment strength sections. Okay, here will be for beams. Look here, strength. Okay, this is the strength levels. Okay, and I will show you here about it is shear force, axial force, strength. Okay, so all these are I have defined here. So it was not defined in ETABS. Okay, so if you do not know, you can just copy and put in your structure this capacities factors. So afterward, I'm coming to the M1, M2, M3 strength section for columns. So look here, it is the nominal strength, tension, compression. So if you get structure or a building from another software, make sure all these points will be not predefined. I have inserted these values. So there will be very big challenge which value to put, how to choose tension value, how to choose compression. So this will help you to remove your burden and just simply put these values. So all about these values will be not available when you get a structure exported from another software. So that is why I'm explaining here briefly and or in a detailed manner, okay, to make all the viewers understand about all these challenges. So afterward, I'm coming here to the strengths, shear strength section with 3. So look here, we will have these labels. So afterward, I'm coming here to inelastic, then I will come to elastic, then I will come to the cross sections, and finally to the components. So inelastic, I will come here to the beam sections or column sections, like I will define here a moment rotation. These will be taken from or assigned in ETABS, so there will be no need to define all these moment hinges. Define and assign all these rotation type hinges and ETABS. There is simple and automatic. Here is very big problem. So I will show this bit 12 in the 6 hinge properties. So here, look, all the information will be shown here. Okay, strength losses and all. So if you just want to check another hinge, this is the rotation hinge for beams. B mean for beams, and C will come for column, and W will come for wall, shear wall. So afterward, I'm coming here to the column. In the column, I will show you PERFORM-3D hinge concrete rotation type. So look here, these for column, like I have different columns. Okay, so all these properties will be about column, tension, compression, and all other deformation values. Okay, and select degradations and section dimension. So strength losses and all. Okay, and you will choose here the shape, deformation, cross section, and it is strength loss, all these information. So I will come here to this column. So the different deformations and section dimensions will be put it here. So after I'm coming here to if you use dampers, you will put here in rubber type. Okay, dampers. Okay, I didn't use dampers. If you just want to use it, so here will be the rubber type seismic isolators, and here will be the seismic isolator friction pendulum. So afterward, I'm coming here to the strength sections. So strength sections I have discussed. I think I will come to the elastic. I will just define here. So like here axial strain gauge, I will define here a strain gauge, and I will put these labels for compression and tension. All these 3 labels. Okay, and now I'm coming here to the cross sections. Coming here to the beam reinforced concrete sections, RCC, and I will come here to this beam. This is beam section and axial area, and all will be just automatically calculated after putting these sections values and pressing the calculate. But I will put here the modulus, Young's modulus, and Poisson's ratio and shear modulus will be calculated after putting Poisson's ratio and Young's modulus and pressing the check. This shear modulus will be calculated automatically by the system. So now I'm coming here to the column. So and I will choose here this column. This is dimension for column. This is section properties. Okay, So, and this is Young's modulus and Poisson's ratio, and this is the shear modulus. So after checking it, the graphs will be shown here. Then I will save it. Now I'm coming here to this shear wall section, shear wall inelastic. So all these, this is for shear wall. I have defined it manually, okay, not in ETABS, okay. So like you will choose and define here this wall W22H3. So you will choose here auto size. So afterward you will choose material, it is wall thickness, okay, percentage thickness, and number of fibers and others. All these are about the shear walls. So afterward I am coming to the slab or shell plastic section. Okay, I will choose here the slabs. I will choose it is material type, okay, it is effective thickness, and it is okay membrane, and this is the bending, this is membrane, okay, and I will choose here the slab thickness as well. So afterward I will just press a check. If everything is correct, I will just save it. Now I'm coming here to the components. So in the components I will just practically assign and create some sections. So like come here, look, this is the beam section, so compound beams. So all the properties I have inserted here, the component about beams. So like different components, you can just look here. So now I'm coming here to the shear wall compound components. This is about shear wall, okay. So all the wall thickness, Young's modulus, and effective wall thickness is shown here. So now I'm coming here to, okay, there is no need to others to explain. Okay, now I'm coming here to the elements section. So you will have different element groups. For example, this is for columns. So like you can just select these columns, okay, it is properties, okay, column properties. If you just select one column, so you will see its properties here. If you want to just zoom it, you will press this one and you can just drag, okay, it will be zoom. So you can just press this column, you will see everything. So and you will just assign its components. Okay, I just want to clear this section element. Okay, I will choose this column, and you can see it is properties, it is type, it is name. If you just want to assign its components, you will assign from here. If you want to see it is properties, okay, all properties will be shown here. Look here, this is about the column properties. So now I will choose here beam sections. Okay, this is about the beams. If you want to just zoom it, this is beam. Okay, all the information, type and name is shown here. If you didn't assign it as properties, okay, you will assign from here. You will choose component as a beam, and you will choose the beam component here, and you will just press assign. So I do not want here now to assign it because I have already completed this one. So now I am coming here to show you shear walls. Okay, this is the shear wall which I have created, okay, in the structure. I will just zoom it a little bit that you would be able to see it clearly. Okay, this is the shear walls. Look here, you will see its properties. Okay, so all these is about the shear wall. You can look at its properties. It is orientation. Okay, orientation about the shear wall, this portion. If you want to just add some element, you will add from here. The shear wall element about its sequence, you will choose the nodes like this. And for about, if it is about column method, you will choose here. If it is row method, you will just choose different 4 nodes. You will just press 1, 2, and it's by sequence, and you will choose test and confirm. Okay, if you just want to show from grids, you will choose 1, 2, 3, 4, like one node here, another node here. I will show you here. For example, I will choose like here. If I choose like this one node will be here, so one node will be here, and third, fourth. Okay, if you want to just delete some element, you will choose like from here. I want to just delete this one. I will test. Okay, look here, it has been removed. If you want to just delete it, you will just press OK. If you don't want to delete it, I will undo it. So I don't want to delete this one. If you want to just change it as group, you will choose here, and you will just press this one, and you will change the group. Okay, if you want to just delete this element, you will come here, test, and OK. Okay, like I will cancel it first. I will come to cancel. I want to delete this one. I will test, and I don't want to delete. So now I'm coming here, coming to, this is also about the strain gauge. Okay, all I have defined here, these are the strain gauge. So if you want to just do some, it is property check, it is group information, it is orientation, or other element, change the group, you can just do from here. Look here, it is strain gauge, it is element type is deformation gauge. So all information will be shown here in this element section. So like in column the same, it is properties, it is group information. Okay, it is orientation, change the group. Okay, from here, and if you want to just delete, you will come here, you want to delete this column. Okay, you will just test, look here, it has been removed. Okay, if you want to just press OK, it will be delete. If you don't want, you will just press undo. So now I'm coming here to add or delete frames. Okay, so if you want to just look here, I have different views. Okay, like wall stack, I have story wise. Okay, it is 29 story, I have 20 story, 15, 9, 8. So all stories base. Okay, so you will come here, P, this is this level. So if you want to just delete some nodes from here, if you want to just duplicate them, some nodes, you will press select some nodes. Okay, like I'm just choosing the entire structure, so you will press some node and you will duplicate from here about X directions, Y directions for vertical. So you will create all these waves from here, so you will be able to move it freely and without any problem. Okay, so afterward I'm coming here to the load pattern. So you will choose here about, like I will choose first here in these portions. Okay, the entire structure. Okay, then I will come here to the load patterns. Look here, it is about accelerations X axis, and this is about Y axis. So you will see here about the load pattern, which loads has been applied, okay, whether it is nodal, it is elemental loads, okay, or it is self-weight, like it is self-weight about the columns, okay, self-weight about beams. I will just little bit zoom it, and this is the self-weight of shear wall. It is in blue color. If the self-weight or the load pattern has been applied, okay, it will show in blue color. If it did not applied, it will show in different color, okay. So it is like blue light if it is applied, okay. It is the self-weight about like strain gauge and all. Like look here, the self-weight did not applied here, it is in different color. And when I come here to the columns, okay, it has been applied here, it is showing in this type of color. So now I'm coming here. If you want to just import some or export some information or data, you will come here. And this is about drifts and deflection. Come here, it is drift about each one directions, okay. Look here, story wise, okay, it is 30 story drift about each one direction. I will zoom it. Look here, it is about each one direction, okay. When I come here to the 29 story, it will be shown here. It is drift about each one direction, and same for each and every story, it has been different and has been applied. Like coming here to the 4th story, this is the drift about each one directions, and I will show you also about each two directions, okay. Like look here, it is about each two directions, okay, it will be different. And if you want to just see here about each two directions, it will be shown as well, okay. This is the drift about each two, and the previous one was for each one. Look here, this is for each two, and I will show you for each one as well. Look here, this is for each one. I've chose here h2. It is showing about this axis or x-axis. It is drift. So I will come here down, basic view. Now I will come here to the deflection. It is deflection about each one direction. So look here, it is about each one direction. And we can just look about each two direction as well. I'm coming here to the deflection. Here, this is the deflection about 12, 15, okay, and others. So this was about the drifts and deflection. Now I'm coming here to the structure section. Look here, it is like base cut, okay, and story wise cut as well, okay. 29 story, it is 26 story, okay. I will zoom it, and look here, it is reference point and element group has been shown here. Look here about each one directions, h2 v, and also it is element group, it is columns. If you choose the beams, okay, it will be different. So look here, it is different. If you choose here, it is strength, you can just look, it is strength, okay, and some groups. After defining the sections, okay, I will create here the groups, okay. Like look here, it is P1 group, okay, and choose here the story. You will like this group has been created here, all these points has been added. So about this, the specific story, and it has been added and assigned this section. If I change to P2 level and choose here like this level, it will be different, and about the story wise it will be different. So now I'm coming here to the limit states. This is the limit state about deformation, like here about the beam, immediate occupancy, and also about the limit state of the beam, okay, level 2, and this will be level 3, collapse prevention, and this is the DC ratio limit. Okay, now I'm coming here to the immediate occupancy about column, level 1, limit state of column level 2, and the same collapse prevention of column level 3. Now I have shear wall compression, okay, and also shear wall tension. All these limit states I have defined, okay, so that's why I'm just explaining and do not talk in very details, okay. So please watch the previous tutorials as well, okay, you will understand much more about that one, and if you do not understand there, watch here, okay. And it is about beams rotation and also column rotation and PM2 M3 hinge about the columns. Okay, now I will choose here the strength section. I have defined the strength of limit state of beams. Look here, it is moment strength section, and you will choose from here the condition. The condition should be added here. Like all this condition is showing here, which is listed the condition I have chosen from here. You are also going to choose from here this condition, and after just adding you will save it, and you can choose it is limit and everything, and it is performance level from here. So like this, which is showing here in yellow color, I have been chosen here the condition, and I have added and I have saved already, okay. So you will choose and follow the same procedure. So if there was any mistake, so it will be showing there, so you have to correct that mistake, okay. So now about column strength, I have added this limit state about PM2 M3 strength section and about shear strength section, okay. So like I was chosen here the strength limit state, okay. So like I have defined this for shear walls and for column axial strength. You will choose condition from here, you will add it and we save it, okay. Now I'm coming here to the drift limit state. I will choose here the given like each one direction, and I will choose here it is limit, like look here, it is positive limit is drift limit is 0.035, and the negative drift limit is also 0.035, and I have chosen and selected here the highlighted drift only. I will select and highlight about each one directions, each and every story, like 1 story, 2, 3, 4 up to 30 story, okay. I have highlighted all, and afterward I will save it, okay. Same is for each two. I will highlight now, and first I will put here this positive drift limit and negative drift limit, okay, and I will highlight each two drift about 30 story, 29, 28, 27, 26 up to story 1, okay. Now I will choose here one dummy drift limit as well, okay. I have defined it before and here in the drift section, okay. Here I will define the drift, this dummy drift, okay. So I will choose here the positive drift limit for dummy drift 0.1 and 0.1 in both direction, okay. I will highlight this one, and I will just save it. Okay, so, and I will come here to the drift limit state, sorry, for deflection limit state. Okay, I have just highlighted all the deflections, okay, here, and I have chosen it is limit as a 0.1 about positive, and same is for negative deflection limit. Okay, so now I'm coming here to the limit states about structure sections. I have chosen here the point which I was created up in the section here, in the sections about here, and I was grouped. This is that group which I am going to define it is limit state. Okay, I have added all that point about it is shear strength. Okay, and it is levels 1 to 3 up to 5 levels, and it is DC limit, and all these, like I were created there two groups for shear walls, and this is the second group. So all these were about limit states. Like now I'm coming here to the final point, like press this one. Okay, so like choose element we can look at, but it is not required now. After explaining and completing all these sections about the modeling phase, I just want to move toward it is analysis phase. Come on, I will choose here it is task about load cases. Okay, which I'm going to explain here in the load case. First, I will define it as gravity. All these earthquake 1 into y1, earthquake y2, all these event xy, all these are predefined in ETABS software, so that is why it is showing here. But I will define here this gravity. I will choose linear. I will put it is load pattern, okay, as a self-weight, okay, and I will save it. That's it. Afterward, I have defined here the dynamic earthquake or nonlinear dynamic earthquake record. I have defined all the earthquake records here, like 1, 2, 3, 4, 5, like 11 earthquake records I have defined here. Where it is showing here the 4 earthquake records, the maximum I were defined 11 earthquake records. Okay, it is up to you how many earthquake records you're just going to analyze the structure. Make sure this is the high-rise building, 30-story. Analyze it for maximum earthquake records as possible. Okay, maximum credible earthquake records taken from the earthquake database. If you do not know how to get the earthquake records, watch another tutorial where I will put its links in the description box. So I will define here the earthquake record. Okay, I will put here it is name, okay, load cases, and afterward I will just add a record here. I will browse the earthquake record from here. I will choose all these information. So afterward I will just return back to, so that's why I do not want to define now, okay, because I have already defined. Okay, like look here, the 4th earthquake records about Japan, Kirin, Imperial Valley, and then earthquake records I have already defined here. So all the information about it is time, total time, it is time difference, okay, the maximum point, and it is limit, everything is shown here. So I have already analyzed the structure, that's why it is information is showing here. If you did not complete it is analyzations, you can't find all this information. It is analysis phase. Okay, after load cases I am just going to move toward it is analysis series. So afterward you will check its structure. If the structure was okay, you will just proceed with it is analysis series. You will define earthquake from here. Okay, like I have defined 1 2 3 4 earthquake records. Like this is Japan earthquake. Okay, this is Bam Iran earthquake. This is Korean earthquake, and this is for Kobe Japan earthquake. Okay, you will choose here it is series name, it is description. You will come here to it is masses. You will choose the standard and geometric nonlinearity. Okay, effects, and you will choose it is masses, it is mode shapes, and you will choose it is damping ratio if you want to just change here. Okay, and it is relay damping, all this information, and afterward you will just press come to okay. If the structure was correct, all properties were assigned, the orientation was correct, okay, everything was okay in the modeling phase, okay, you will proceed to run the analysis. If some problem was there, the system will not allow you to proceed further before correcting the previous mistakes. So here in the analysis, which I have already also explained in previous tutorials, okay, you will just add the load case from here. So, and you will put here all the information, and you will just press simply go. If you want to analyze for all the earthquake records, okay, then you will choose like the simple one earthquake record, and you will don't go, that earthquake record will be saved. And if you define all the earthquake records and add in the list, analysis list, and all the 4 5 6 or whatever earthquake records you want to analyze the structure, if you add all the earthquake records in the system analysis list, so afterward you will just press simply go. So the structure or the building will be analyzed for each and every individual earthquake record. So these structures I've already analyzed and completed. It is analyzation for all the earthquake records. That's why I do not want to start it is analyzation again, because it will take like maximum time. So now I am simply going here. If you want to just analysis parallel, you will press here, okay, to analysis parallel, okay. And if you want to just import some result from some another source, you will press here. Okay, I will show you here its modeling analysis results, okay, because the structure analysis has been completed. Okay, I will show you the result about each and every earthquake record. Okay, like look here, it is mode shape. I wanna show it is mode shape 1. Okay, look here, it is mode shape first, second mode shape, third, fourth, okay, 8th, 12, like this is 21st mode shape. Okay, like total I have 50 mode shapes. If you want to just animate, you will press here, it is animate. Okay, look here, the maximum structure displacement. So this is it is animation. This is 30-story structure. Look, and look, it is animation is very properly and without any mistake. Okay, I will stop it now. So this is about the nodes and all the drifts. Okay, if you want to just save it as information, you will highlight it and you will save it. Okay, if you want to select and show and save all the information about its drift, you will highlight, select all, and you will save it. Okay, and you will save it to the notepad. Okay, and it is section properties. Okay, look here, if you want to see it is information, okay, you will just press show here, and you will choose here it is force unit and it is length unit as well. Okay, and this is about the energy balance. Okay, look here, I will show you it is energy balance. Okay, about earthquake 1. Okay, and this is about earthquake 2. Okay, plot, and it is about earthquake 3. Okay, plot, and earthquake 4, plot. Okay, it is like different energy plots. Okay, if you want to show it is about element wise, you will show for columns, okay, beams, shear walls and others. Okay, for each and every earthquake code. Now I'm coming here to the limit states in the analysis phase. I will choose here the limit state. If you want to just define here for each one of two directions, okay, you can just add. Okay, so now I'm coming here to the deflected shape. Okay, so you can just look here, it is time history graph. From here, if you want to just plot animation, you will plot it. Okay, so the animation desired will start, okay, in progressing the time. The structure will vibrate in start, it is animation, or it is plot will be like it is displacement about the structures will be seen after a while, like look here, after some time. So you will see it is displacement. Okay, so it will take time. Okay, and that's why it is take time, and it is very heavy structure. Okay, 30-story structure, so that's why the plot will take time. And this is the time history about the first earthquake record. Okay, so that is why the system will also become a little bit slower to animate this plot option. And you can just show and see here for the limit state as well, and the scaling. Okay, the scaling for displacement factor and others. Okay, so the system has been become very slower because I have just pressed it is plot. That is why the system is going to start its animation. And regarding this this time history graph, I have stopped its animation. Okay, so you can look here for another earthquake as well. Okay, look here, it is time history graph, and for the limit state as well, you will choose all the deformation and strain stage, or all deformations or all strains. Okay, the group wise. Okay, and you will put here it is the minimum ratio for colors. Okay, like black, okay, and other colors. Okay, up to red one. Okay, which is like the calypso. Okay, so you can just choose and make the plot. Okay, but if it is like very heavy structure, it will take like more time to plot. Okay, and when to reach this limit state, if it will stop or show some information about its calypso. Okay, so some elements of the calypso to be filled. So now I'm coming here to the time histories. Okay, this is the time histories sections where I will say it is relative displacement, okay, relative acceleration, okay, or velocity, or absolute acceleration. About it is translation, each one is true in vertical, and it is rotation, about each one is true or vertical. And you can just choose it is limit, okay, about meter, centimeter, inch. In the single node or multiple node, I want to do here for a single node. For example, this node I want to See, it is relative displacement results. Okay, it is transition and meter unit, and I will plot. Okay, the plot is also different for each and every epoch. Okay, so this is for relative displacement record. Okay, look, see, it is information. If you want to just export or print this graph information, you will press here the print, and you will choose here it is information and preview. Okay, you can just do some adjustment here, and you will look here how many pages you want, and you will print it. You will see this file as a PDF version. If you want to see and save the results as an Excel sheet wise, you will find from here. So you will export this result to Excel sheet, and you can just draw and plot these graphs manually in Excel sheet. So like now I want the absolute acceleration for earthquake 1. Okay, so I will choose here this time it's 2 directions, and I will choose this node. Okay, and I will plot it. So it will take some time, and after a while we will see it is absolute acceleration graph about H2 translation. Look here, this is about H2. If you want to see it is H1, okay, rotation this time, you will see different graph. And look here about another axis. Okay, so if you want to see for multiple like this nodes, 2 node, okay, you will just save it as information, maximum or minimum point, or save the time histories. From here you will just plot and save it as results. If you just want to save it as relative velocity, you will choose from here. You will choose the direction. Okay, and this time I want a single node. Okay, I will choose this node, and I will plot. Okay, this is the graph about relative velocity in each one directions. Look here for each 2 direction as well. This is about each 2 directions. Okay, if you want to just print it from here. Okay, so, and if you want to save it as result to a file, you will put here this, press this button, and you will plot this graph manually in Excel sheet. So now I'm coming here to the hysteresis slopes. Okay, about the column beams and shear walls, you will see it from here. You will select that element and you will just plot. Okay, so like it is very simple. Okay, we can just plot, okay, the loops. Now I'm coming here to the moment and shear diagrams. I will press this one, and now coming here you can just see for a single element. Okay, you will choose here it is element type, and it is moment and shear diagram. Okay, angulationally or time histories or diffracted shapes. Okay, you can just do from here. And if it is a line element, okay, like 1 2 3 4, like on the line, okay, I wanna just look here, I want to plot it is bending moment or shear diagram. Okay, I will choose it is force unit. Okay, and it is length and also unit and plot. Okay, the section element must be in the line or concept. Okay, I will just clear it, means it should be consecutive. Okay, I will plot. Means like you should select the elements in the line which is connected together. Okay, this is the shear and bending moment diagrams, okay, about that elements. Look here, different elements. So look here, this view. Okay, so like you can choose the different elements from here and select, and afterward choose the moment and shear diagrams, okay, and press the plot and choose units as well. If you were satisfied with that results, you can just export to PDF file or just Excel sheet. Now I'm coming here to the general pushover plots. Okay, this will be generated when you have conducted the pushover analysis. Okay, but I did not conduct it at the moment, so the next time I will do here for pushover analysis also, and I will show you it is pushover graphs here. Okay, and I will show you it is pushover graphs as well. Okay, so these two, and here is the target displacement as well. Okay, for different steps. Okay, it is showing here, and also now I'm coming here, it is DC ratio, okay, or demand over capacity, okay, ratios, and right look here all. I will choose here the earthquake reports and I will plot. Look here, this is the usage ratio graphs, okay, and if I choose the all drifts, this is for drifts, okay, and this will be for deflection, okay, so, and strengths and all the deformations, okay, you can just see from here as well. Okay, so like this is the combination in dollars. Okay, all these were about it is modeling phase, it is analysis phase, and different steps and procedure. I think this tutorial will help you a lot to learn more about it is modeling phase, it is analysis phase, different procedures, graphs, bending moment in shear diagrams, deflected shapes, drifts, drift limits, limit states, shear strengths, and all other deformation of different element of the structure. Okay, so thank you so much for your attention, and do not forget to subscribe this channel. Channel subscription will persuade me a lot to create different videos for all of you, and press the bell icons for getting the quick notification while uploading the new tutorials. Have a wonderful time. Bye bye.